This video is brought to you by Academy of Higher Learning. Hello and welcome to today's video. In this video, I'll be talking about quotient rule. So basically, I'll be going over the rule, followed by the proof, and then a few examples. So let's start. The rule. The quotient rule goes as following. Let's say if we have r of x equals p of x over q of x. So let's say p of x is the top function, and q of x is the bottom function. So, spelled that wrong. Okay, so the quotient rule states that the derivative of r of x would be r prime of x equals the derivative of the top function, p prime of x, times the derivative of the bottom function, q of x, minus the derivative of the bottom function, q prime of x, multiplied by the top function, p of x, all over q of x squared. So that's pretty much the quotient rule. And for the record, you can find a derivative r prime of x using the product rule. So basically what you have to do is, I'm going to change the color. Um, so we just have to put the q at the top. So it'll be p of x times q of x to the minus 1. And basically we will have to use the product rule and the chain rule combination to find the derivative, and the results will be the same. And this also works vice versa, so you can take this and put it at the top and use the product rule. But like I would suggest that you learn the quotient rule because it's more efficient that way. Like you can solve the you will have to worry about one less step. Like you don't need to use a chain rule, so it's better to know the quotient rule. Alright. So next is the proof. So basically the proof is really simple. In this proof I will be using the product rule, which I've already proven in my previous video. So first, again, we are going to be using r of x equals p of x over q of x. So first we have to just rearrange it, multiply both sides by q of x. So in this side it will be just p of x and r of x here times q of x. Next you use the product rule here. So product rule. So basically d first second plus d second first, and then you just divide both sides by a common denominator, which is wait, oh sorry, you subtract you bring q prime of x times r of x to the other side. Then you divide it by q of x. So change the color here again. So orange. So you divide both sides by q of x. So it'll be r prime of x. You just isolate it then. P prime of x minus r of x times q prime of x all over q of x. So basically we are done, but let's just get everything in terms of p and q. So expand r of x. So that will be p prime of x minus p of x over q of x times q prime of x all over q of x. And now let's just multiply top and bottom by q of x. So that will be q of x over q of x, and these two will cancel out. So you'll be left with p prime of x times q of x minus p of x times q prime of x all over q of x squared. So basically this is a proof, and I've used product rule once again. Next is like the way I memorized it. So again, given r of x equals p of x over q of x. So basically I kept saying this stuff, low d high minus high d low all over low squared, and d is coming from here, the differential that is used. And that's pretty much it. Like if you keep saying low d high minus high d low all over low square, I'm pretty sure it'll get stuck in your head. I personally had a hard time memorizing it, but eventually I got it using this stuff. So next is the example, and the example that we have here is h of x equals 3 of x minus 4 all over x squared plus 5. So let's say that the top is p of x and the bottom is a q of x. So I'm going to write it here. P of x equals 3x minus 4, and q of x equals x squared plus 5. and I'm gonna substitute it with p of x and qx. So p of x over qx. And next is applying the quotient rule, which will be h prime of x equals low, meaning the bottom function. So this is high over low. So low d high, so p prime of x, minus high p of x, and d low, so it's q prime of x, all over low squared, so q of x squared. So pretty much we just need the p prime of x and q prime of x, and we can get it from here. So p prime of x is basically 3, and q prime of x is 2x. So we have pretty much everything. All we have to do is sub these 4 into here, back into the equation, and we'll get the answer. That will be um, x squared plus 5 times 3 minus 3x minus 4 times q prime of x, which is 2x, all over x squared plus 5 squared. And this is pretty much the answer. It's the answer, and it's I haven't simplified it, and you can expand these the top part and collect common multiples. I mean common terms. Sorry, and yeah, I haven't simplified it yet. So just because of time's sake. And pretty much we're done. And again, we can do this using product rule, and I'll show you how. I'll have to rearrange it. So product rule, and basically what you have to do is say if we have h of x 3x minus 4, this is the top function, and you just have to bring this at the top, so it'll be x squared plus 5 and to the minus 1, and then you just use a product rule and chain rule in combination. But this is much faster because it's just one step versus this is 2 steps, product and chain. So here are 2 examples. You can try yourself. Pause the video. Now I'm going to show you the answer. So for the first one, there isn't the answer is, I haven't simplified either of the answers, but there is a simpler way of doing it. But since this video is basically quotient rule, I just had to do in quotient rule. So the simpler way is just dividing root x from the top term. So it'll be 2x 1 half plus 8x minus 1 half, and then you can just use the basic rules to get the derivative, and it's much faster doing this way. And for this is the very efficient way. Basically what you do is, instead of like expanding it, like putting 8 in both terms, you do the chain rule. You do the chain rule, and then you apply the quotient rule to it. So that's pretty much the end of the video. Thank you for watching the video, and if you have any questions, you can always like ask us. And yeah, and also you can visit our website at www.ahl.info to view more videos like